everyone, and welcome! So today we're going to talk about a shape that you see literally every single day, but you probably don't really see it. I mean, it's hidden in plain sight everywhere, from ancient pyramids to giant modern bridges. It's the secret backbone of our world, and we're about to find out why.
So to kick things off, let me ask you a question. What could the Great Pyramids and, say, the Golden Gate Bridge possibly have in common? I mean, think about it. They seem like they're from totally different worlds, right? But they actually share the exact same fundamental blueprint. A single, incredibly powerful shape. And that answer? Yup, it's the triangle. This super simple, three-sided shape is the foundation for a mind-boggling amount of the stuff we build. It's basically a geometric superstar. And today, we're going to figure out exactly what makes it so special.
Okay, so not all triangles are created equal. You can kind of think of them like a big family with different branches. We can easily sort them into three main groups, and the rule for doing it is super simple. It all just comes down to the length of their sides.
First up, let's meet the perfectionist of the family, the equilateral triangle. The name pretty much gives the game away, right? Equi means equal, and lateral means sides. So, you guessed it, all three sides are exactly the same length. Perfect.
And check this out. This is where we see a really core rule of triangles in action. What happens with the sides is kind of mirrored by the angles. Because all three sides are equal, all three of the inside angles are also equal, and each one is a perfect 60 degrees. This perfect symmetry, this harmony, it's our first big clue to the triangle's secret power. All right, next in the lineup, we've got the isosceles triangle. This one's a little different. Its defining feature is that two of its sides are equal in length, but that third side, it's the odd one out. And just like we saw before, that same rule holds true. Two equal sides means, you guessed it, you get two equal angles. You can see them right here at the base. It's this perfect, totally dependable relationship.
And last but not least, we have maybe the most varied member of the family, the scalene triangle. You could almost say its rule is that there are no rules. None of the sides are equal, they're all different lengths.
So, you can probably guess what's coming next, right? If none of the sides are equal, well, then none of the angles are equal either. Every single side has its own unique length, and every angle has its own unique measurement. Total chaos! All right, time for a little pop quiz. Let's put what we just learned to the test. Here's a triangle, and we've got all the info we need right here. The length of each side and the size of each angle. So, take a good look. Based on what you see, what kind of triangle are we looking at here? Is it equilateral, isosceles, or scalene? I'll give you a second. Did you get it? If you said isosceles, you are spot on. You can see it right there. Two sides are 36 centimeters, and look, two angles are 67 degrees. The rule works perfectly. Okay, so classifying triangles by their sides is one thing, but there's something else. A universal, unbreakable law that applies to every single triangle in existence. No exceptions. Seriously, it doesn't matter if it's a tiny triangle you doodle on a napkin or a massive one formed by stars in a galaxy far, far away. They all share a secret magic number. This is one of the most fundamental rules in all of geometry.
And that number is 180 degrees. Here's the key takeaway. If you add up the three angles on the inside of any triangle, the sum will always be exactly 180 degrees. Not 179.9, not 180.1. Always 180, period.
Now, how do we know that for sure? Well, check out this super elegant visual proof. Don't worry about the text, just follow the logic. If you draw a line through one of the corners that's parallel to the opposite side, watch this. Something amazing happens. The three angles from inside the triangle, they just kind of slot perfectly into place along that straight line. And what do we know about a straight line? It's 180 degrees. So it's proof. The angles inside have to add up to 180. It's just so simple and beautiful.
Okay, so we know sides and angles are connected, and we know all the angles add up to 180. But the rabbit hole goes a little deeper. There's an even more direct link between the length of one specific side and the size of the angle that's right across from it. And the rule is just wonderfully simple. The biggest angle in any triangle, it's always going to be sitting directly across from the longest side. And on the flip side, the smallest angle is always going to be opposite the shortest side. It's a perfect matchup every single time.
This diagram shows it perfectly.
Again, just focus on the picture itself. See side AB? It's clearly the longest one, right? Now just draw a line with your eyes from that side across the triangle and you land right on angle C. This rule guarantees that angle C has to be the biggest of the three. It's not a maybe, it's a must. And this direct link is another key to the triangle's power.
All right, let's pull all these threads together. We've sorted triangles into their families, and we've uncovered some of their most fundamental rules. But so what? Why does any of this actually matter? What is the triangle's secret strength? So here are the big takeaways. First, we classify triangles by their sides: equilateral, isosceles, and scalene. Second, there's that universal law. All the angles inside any triangle always add up to 180 degrees. And third, there's that unbreakable link. The longest side is always across from the biggest angle. Got it?
And all of this brings us right back to where we started. Why this shape? Why is the simple triangle the unspoken hero behind pyramids and massive bridges? Well, here's the big secret. Because those angles have to add up to 180, and because a side's length locks its opposite angle in place, a triangle is just fundamentally rigid. Think about it, you can't change one of the angles without literally breaking one of the sides. It just won't budge. A square? You can easily squish a square into a diamond shape, no problem. But a triangle? It refuses to change its shape. And that simple, predictable, unshakable strength, that is its superpower. And that is why the triangle will always be the shape that builds our world.